So after spending some time on looking at different kinds of sequences, arithmetic and geometric sequences, as well as some recursive ones, now we're going to look at the whole idea of a series. Now, if you're looking at a specific series called an arithmetic series, it's really just the sum of the terms in an arithmetic sequence. So basically, if you take an arithmetic sequence, one of the ones we've been looking at already, and we add the first n terms, we choose what n is, so n could be 20, we could say we add the first 20 terms, that would be an arithmetic series. So basically we take a certain number of terms, add them all together, and that would be an arithmetic series. So just as an intro here, there's an old story. I don't know if it's actually true. It's on the internet, so that means it probably isn't true. But Gauss, famous mathematician, back when he was in elementary school, one of his teachers, as a challenge, just as sort of like a make work project, asked them to add up all the numbers from 1 to 100, figuring it would take them a very, very long time. So he was a bit of a smartass, so we decided to try and find a shortcut. So when most people in the class were just doing 1 plus 2 plus 3 plus 4 and trying to work it out, remember this was in the days long, long before calculators, he decided to try and find a different way. So what he did is he, again, if you believe this story, he took all numbers from 1 to 100 and wrote them out like so, the way I have, 1, 2, 3, all the way up to 100. And then right underneath, he wrote all the numbers in reverse order. So you'd have 100 plus 99 plus 98, and so on and so forth, all the way down to having 3, 2, and 1. Okay, and the reason he did this is once he had everything lined up here, he could take a look at each column and say, hey, look, 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101, and so on and so forth. Every single pair of numbers here is going to add to 101. So then you decide, okay, well, how many of these 101s do I have? Well, I actually have, because there's 100 numbers in this series here, going from 1 to 100. Basically, what this is equal to is 100 copies of 101. So then you decide, okay, if I want to figure out what the sum of all these numbers is, well, it's just going to be 100, because there's 100 numbers in it. And then 101, because every pair of terms add up to 101. Now, by adding these two together, he's actually added together two copies of this series. He only needs one, so it was 100 plus 101 divided by 2. And that's how we found the sum of the first 100 terms. And what this actually leads to is sort of like a general form here. If you're taking a look and trying to find the sum of a certain number of terms in a series, well, what this is actually saying is, well, 100 is the number of numbers in here. Okay, so because there's 100 terms in this sequence, we could just call that n. 101 was got by taking the first term in the sequence and adding it to the last term in the sequence, so we'll call the first term t1, the last term tn, and then dividing by 2. So we found the sum of the first n terms in a sequence by taking the first term, adding the last term, that's why we got 100 plus 1, multiplied by the number of numbers in the series, or sequence, in this case it was 100, and then dividing by 2. This is one particular formula for adding the first n terms of a series, okay, or n terms of a sequence. So looking at a potentially different way of finding the sum of the terms in a sequence, so we have the formula that Gauss kind of figured out, allegedly in elementary school, and now let's take a look at another way. So if we have an arithmetic sequence, let's take a look at all of our terms here. So we're going to have a for our first term, and then our next term is going to be a plus d, because we're adding a common difference to each term. And we keep on going n times until we get our general term a plus n minus 1d. If we take what Gauss did and just reverse the order of everything, and just write that underneath, well, we have the last term being a plus n minus 1d, and then going down all the way until a. And then we're going to do what Gauss did and then add these two together. Okay, so if you add these two together, again, I'm calling Sn the sum of the first n terms, so I add them together. I have two of them. And if I add all these terms together, I wind up getting the same thing over and over again, just like Gauss did. So I have a plus n minus 1d. Well, the a's just simplify into getting 2a, and that's going to happen with all of them. So here my a's add together, I get 2a. Here I get another d added to this n minus 2d to get n minus 1d. So what I wind up with is n versions of this 2a plus n minus 1d. Okay, so what that means is I'm going to have 2 times the sum of the n terms in the sequence, first n terms in the sequence, being n times 2a plus n minus 1d. Okay, so to solve for just for Sn, which is again what I'm looking for, is a formula for the sum of the first n terms, I just divide both sides of the equation by 2, and I get this equation right here. So what both these formulas do is, again, Sn, it refers to the sum of the first n terms of an arithmetic sequence. Okay, so now that we have these formulas, we can actually start putting them to use. Okay, so for starters here, looking at the first example, it wants us to find the sum of the first 30 terms of the sequence. So the notation for that would be S30. Okay, so what we're going to do here, let's start by writing out our formula. Okay, so there it is. And because our sequence is arithmetic, we can find out a lot of information here. So our first term is 5. Our common difference in this case is 4, as that's we're going up by 4 from term to term. And what we're looking for, again, is the sum of the first 30 terms. So in this case, our n is going to be equal to 30. So S30 will be 30 times 2 times 5 plus 4 times 30 minus 1. All over 2. And from here on, we're just looking to simplify. Okay, so I'll let you finish this off on your own. Okay, so you should wind up with 1,890. So the sum of the first 30 terms is 1,890. Alternatively, if we didn't have this formula, we'd be doing 5 plus 9 plus 13 plus 17 and following this all the way out for the first 30 terms. So it would take a little while, so it's helpful that we have this formula that's been derived. Okay, let's take a look at another one. So first I wants to determine the sum of 2 plus 5 plus 8 plus and so on and so forth all the way up to 98. Okay, so first off, let's write down everything we know. So it looks like this sequence is arithmetic. We're going up by 3 every single time. So we know our first term is 2 and our common difference is 3. So if I try to approach it just like the last one, I write out my formula for the sum of the series. However, it turns out that we actually don't have n because we know the a and the d, and we know our last term is 98, but we don't know what term number that is. Okay, so we actually have to figure that out if we're going to use this formula. And the same is true if we actually want to use the other form of the equation, which is this, Sn n times t1 plus tn all over 2. And the surface, this one might seem a little bit easier to do because we have the first term, this 2, and we have the final term we want to find out, which is 98, but again, we still don't know what that n is. So what can help us figure this out, I mean, aside from just counting out the number of terms till we get to 98, although that is possible, is actually trying to solve for that. So remember, it's an arithmetic sequence that we're seeing, 2, 5, 8, and so on and so forth. So that means we should be able to find out a general term. Okay, so when in doubt, that's never a bad thing to try and find. Doesn't take too long to do with an arithmetic sequence. So in this case, a is 2 and d is 3. Okay, so when I simplify that one, I wind up with 2 plus 3n minus 3. So I get 3n minus 1 as my general term. So now if I want to figure out what term number gives me a term value of 98, I can just put 98 in for tn and then solve for n. So this becomes a relatively simple equation to solve. I get, when I solve this, n being equal to 33. So now that I have this, I now have two options. I can throw my n, my a, and my d into this version of the series equation over here, or I can use this one down here. Since I have my n, I have my first term, and I have my last term. This one looks a little bit easier to use, so I'm going to use this one. So that would mean if n is 33, t1 is 2, my 33rd term is 98, as we just discovered, and that's all going to be divided by 2. So that gives me a sum of 1,650. Okay, and if you use the other formula, you should have gotten the exact same thing. So hopefully they both worked. But always try to find the easier way. If you have the last term, you don't have to solve for using a general term, then by all means use this second version of the formula. And in theory, you could have tried to use this formula on the previous example as well. The only thing is we would have had to figure out what the 30th term is, and that would have involved creating the general term and solving for it, which might have taken a little bit longer. But since we had everything already to use the longer series formula, we can use it. So again, keep in mind that both these formulas are possibilities. Just try and use the one that looks like it's going to be easier to use. Okay, let's look at another example. So in this case, the sum of n terms is being given by this particular equation. Now, it doesn't say if it's arithmetic or geometric. It doesn't appear to be arithmetic because this is a different equation from what we've been looking at, but it actually doesn't matter. We should be able to solve for what's given here. So for A, let's determine the sum of the first 10 terms. Well, if Sn is the sum of my first n terms, and I want to find the sum of the first 10 terms, well, let's just put in n equals 10 and see what happens. So that'll give me 10 squared minus 2 times 10. So I should have a 10 in here for n on this side as well. So S10 will be equal to 100 minus 20, which is 80. Okay, and now B actually asks us to specifically find what the value of the 10th term is. So I'm going to let you think about this one for a minute on your own or with a partner, and push play and ready to go talk through it together. Okay, so the trick here is you're given nothing about the type of sequence it is. So you can't even create a general term to find the 10th term. But what we can do, since we know what the sum of the first 10 terms is, we can actually figure out what the sum of the first 9 terms is. Because if you think about it here, S10 is technically going to be the sum of the first 10 terms. So T1 plus T2 all the way down to T10. Okay, if we could figure out the sum of the first 9 terms, well, that's just going to be T1 plus T2 all the way up to T9. So if we can figure out what the sum of the first 9 terms are, we can subtract that from the sum of the first 10 terms, and then we can actually figure out, well, once we subtract them, what's left over is just going to be term 10. So we need to do S10 minus S9 to figure out what the 10th term is. So let's figure out what S9 is. So that's going to be 9 squared minus 2 times 9. So it's 81 minus 18, which gives me 63. Okay, so once I have that, S10 minus S9 is just going to be simply 80 minus 63. So that tells me that my 10th term will be 17. Okay. Alright, so there's one final example here. So we're told the 5th term of an arithmetic series is 18, and the sum of the first 8 terms is 128. So you want to calculate the sum of the first 20 terms. So again, 5th term is 18, sum of the first 8 terms is 128. Find the sum of the first 20. Okay, so this one definitely takes some thinking here. Again, let's just summarize what we know. We're told that the 5th term of an arithmetic series or sequence is 18. So T5 equals 18. Okay, and we're told that the sum of the first 8 terms is 128, which means that S8 equals 128. Okay, so I want you to try and think of what that means. See if there's a way you can use this information to try and solve for some information about the arithmetic sequence, and we'll run through this in part 2 of the lesson.